Hello everyone, welcome back to LeetCode Daily Live where I do the daily question raw and uncut. So before we start, I'm going to put timestamps below, so if you want to skip ahead, feel free to do it. So let's get started. We have a medium today, it's called push dominoes, so let's see what we have. So we have a string dominoes, and it is 100k long, and the string only contains LR or a dot, which I guess is like empty slots. So yeah, so let's read the question. So there are n dominoes, and we place each domino vertically upright, like this. I'm not sure what upright exactly means, but so in the beginning, we we simultaneously push some of the dominoes either to the left or to the right. So after each second, each domino that is falling to the left pushes the adjacent domino on the left, and the right does the same thing, like but on the right side. So when I think upright just means that like the domino hasn't fallen yet. So when a vertical domino has dominoes falling from it on both sides, it'll be balanced. So for the purpose of this question, we will consider that a falling domino expands no additional force to a falling or already fallen domino. Right, okay, so that means like if you have two dominoes falling like from the left on the same side, and one on the right, it wouldn't like affect the domino in the middle, I think. So we want to return the string that represents the final state. Yeah, I guess like for this one we do have to look at some examples to like really understand. Yeah, so LR and dot means like which way the domino has been pushed. And do we have any like so all the dominoes are so all the dominoes are upright at the beginning. And the state we want to return is so after the domino, so the state is, so after we have done all these pushes at the same time, which direction the dominoes are at. So for this, so for case one, I think it will be something like, so the first two fall to the right, and then you have a middle one, and then this one falls to the left. I think that's the case. But yeah, let's look at example two. I feel like this will be a bit more helpful. So we are pushing the second one to the left, so it makes sense like these ones goes to the left. And then I guess like by reading this, it kind of makes sense to like use a stack or something to like check whether to check whether like the current domino is standing or like leaning either way. So like for example, like this goes to the left, right? So this domino obviously falls, and then I think using a stack will work here actually. But yeah, let's look at this example like more thoroughly first. So the third one will be standing, even though there are some like L's and R's here. So let's look at this one. So it falls that side. Right. Yeah. So it doesn't have to completely fall for the answer to actually be leaning one way. So like the only upright ones are the ones that hasn't been pushed at all. So like for example, wait actually so for example, this one here, so this block is pushed to the right, and then this is pushed to the left, but then the middle one is actually still upright because it is being pushed to the right and left at the same time. Wait, actually, would a BFS work as well? Because BFS would be ON, which actually would be quick enough um for our purpose. Yeah, actually, I think BFS would work just fine here. So like obviously we start with all these states, and then so when we push this um yeah when we, like, for example, for the second domino, when we push it to the left, like in the next states, this is going to be pushed to the left, right? And this is going to be pushed to the right. This is going to be pushed to the left. So like we can just do that, and then like eventually, like for these ones, because um it is getting pushed both ways at the same time, it will be balanced and it wouldn't actually move. But something like this, so like so you have a right, so like this will become right and this will become L. uh but then because it has been fallen already, we can't like really push it further anymore, I think. Yeah, the other thing is, what if we have like two L's at the same time? So I think it would be something like this case, right? So in the first state, this get pushed to the right, and then this gets pushed to the left. Um, yeah, but this R doesn't actually push this at all, right? So I guess like if we have a move from the previous state, but then it moves an already moved domino, we just don't do anything. So yeah, actually BFS would work here. So yeah, I guess we can just code it up now. Yeah, I guess the coding part wouldn't be too simple as well, since we have to deal with these cases. I think like that's the main thing that we have to consider. All right, so we want to have the final state. I want to make that an array. We can just set all of them as dot at the beginning. So we want to set like Dominoes amount of final states. And then we want so for BFS, we need a queue, which is actually so in Python there is a queue, so we have to use double-ended queue. I think if I'm wrong, tell me below in the comments, but I'm pretty sure there is no queue object in Python. So we have a queue, and then now, so while there are still movements, we want a new queue, and then like at the end, we will set our new queue into the queue here. So this is going to represent the next movement states, basically. Yeah, but before that, at the beginning, we want to add stuff that needs to be moved. So for dominoes, for I guess like for states in dominoes, so if state is equal to L, what do we want to add in here? I guess like we want to add the position, so we actually need the index as well, and we'll enumerate dominoes. So we'll do q append. I guess like we can do the index and also the move that we are doing. and then other and if the state is R, we want to do the same thing, but then it actually goes to the right hand side. So after we have done this, I guess like whatever is in this state can still be changed, because I'm not sure if this is the cleanest way of doing it, but I think that's all the state we need. So for index move in queue, so if move is equal to L and index is not 0, so if it is 0, it can't move the thing to the it can't move the thing to the left anymore, right? So what do we want to do here? I think like yeah, another thing we have to check is whether and another thing is so after we have moved these, we have to change the final state of these things, right? Because like we have pushed it to the left already, or we have pushed it to the right already. It couldn't be changed afterwards. So we'll just do that. So here we can do final state index -1 is still a dot. So if it is still a dot, we can still move it, right? But if it is not a dot anymore, so it has been moved already, we couldn't move it any further, basically. So yeah. Yeah, so I guess like here we just do final state is turned into the left. Yeah, another thing we have to worry about is like when you have a right here and then you have a left here. So let's say like yeah, so you change this to left, right? But then when we look at right, well, actually, like it will be the other way around, because, like how we have written the function, it will guarantee that it will linear sweep like from left to right. So, but like when we look at right, so we turn this into going to the right, but then if there's a left, we actually have to set this back to neutral. Yeah, so I think that's all we have to really consider. Is like if the move goes the other way, so if move is R and index is not the length of dominoes -1, so we can still go further to the right, and the final state is still unmoved. Still unmoved. We can change it to going to the right. Yeah, so these are all the normal cases that we have. Yeah, but how do you want to deal with like these cases, I guess? I think it's like how you want to add it into the new queue as well. Oh, wait, actually, I have an idea. Because of the linear sweep thing, we can actually make another thing. So if the final state is R at the moment, but then our L thing is going to the left. So I guess we can have like a set So move to right. We can have a set that basically checks index 1 in move to right. So if that's the case, so like basically what this is for is to check whether our current domino has been moved to the right in the same like at the same time when it is getting pushed to the left as well. So if that's true, we actually want to set the final state. Oops. Back to dots. And depending on how we add our stuff into the new queue, we might have to like remove some stuff as well. So I guess like here, what we can do is move to right. We can add. Oh, actually, it should be +1 here. Yeah, we can add index +1, and then new queue. Append. So how do you want to set this? Yeah, so the index and then the move, right? So index and then the move. I think like we just do something similar here. So new queue append. Yeah. So when we reach here, if you think about it, that means this is like the ith action, and this is the I plus 1th action inside our queue, right? So that means we would have just added the move to like push this to the right. So we actually here we just want to pop the like this action out, because now that we've figured out that it is actually a standalone thing and we don't need any like additional actions there. So I think that's all, and then at the end we just return and join final state together. I'm not confident this works, but let's see. Oh, it's never closed. Where is it? Oh, ooh. Takes exactly one argument. Oh, I forgot the brackets. I think it's the same thing here, right? I forgot the bracket here as well. Okay, I mean, looks a bit promising, but I feel like there are a lot of edge cases. Yeah. Oh, the output is null. That's not what we want. Wait, how come it is null though? That's actually very strange. Oh, because I put this in the wrong place. That's why. Wait, is it indentation error? Oh, wait. I somehow removed the queue is equal to new queue thing for some reason. I don't know where that has gone to. Unexpected indent. Huh. That's quite strange. Oh, why is that thing? That's where it has gone to. So I think now it should work, I think. Yeah, let's check this case as well. Yeah, so I put the return statement inside the while loop. It's still wrong though. Why is that? Is it because like it's probably like our index here, like something is wrong here probably. So like here our move would be let's just print the move out honestly. So let's print that. Oh, we need to add the test case. Yeah. It seems like the index here is a bit off though. So I guess what we can do here is we can just print Q for every iteration. So we start with this, right? Which is 2nr. So did I forget? Yeah, I forgot to actually add that. And then because like we're actually like the move for the next state, we want to check the domino on the left or the domino on the right. So that's just something I missed. And I think now it should work. Yeah. But yeah, there could be some other edge cases. Okay, never mind. We got it. So yeah, I guess like this question, there are a lot of ways to do it. But essentially the intuition here, like why I thought of BFS is that we are like for BFS, if a node is seen, you wouldn't do anything to it anymore. So that means like if we have n nodes, we will only need on time. So that's the first thing. The second thing is like we want to somehow simulate the movement, right? So like for example, for this case here, in at time 1, this will get pushed to the left, this will get pushed to the right, this will get pushed to the left, and so on. And then at time 2, this will push this to the right, and this push it to the left, and therefore nothing happens. So we can like keep simulating until the state is stable, so there are no more pushes anymore. So that's kind of where I got the intuition from for this case. But yeah, I think like other than that, I don't have too much to say. And yeah, if you're gotten here, thank you for watching the whole video. And if you have any comments, please comment below and tell me about it. So yeah, thanks for watching, and I'll see you tomorrow. Bye.